Welcome everybody to our 93rd AIM Sports Learn Fast webinar. This is the 19th of 2021. We have a fantastic guest, a longtime friend of mine that is going to join us today. Ian Berwick is going to be here from PAGID Brakes. We were chatting about how to say it correctly, so I will we'll chat about that just so everybody gets a good clear picture on that. The topic of brakes is something that comes up a lot in motorsports. Obviously, it doesn't matter if it's sports car, road racing, oval track, IndyCar, off-road, UTVs, the pro trucks, whatever it is, the brakes are a critical part of it, and it's one of the areas that I notice when working with customers in data, that they really look at their acceleration rates and their corner speeds, and they look at their top speed at the end of the straightaway, check gearing, and they use the data for understanding that their engines are running fine, and oil pressures are good in water. But one of the things that a lot of folks think of third when they're looking at their data is that slowing down rate or the braking, and ways to improve that. And it's to me it's that a third of the triangle, acceleration, cornering, and braking, and it's the one area that people don't work on as much as the other two. So I always like to push the idea of, boy, there's a lot of time to be gained, and there's a lot of work to be done under this braking piece. And so we've had some discussions about the braking side in previous webinars and some videos, and the guys will probably link some of those in the chat box. And but it's something that's important. So I wanted to bring somebody in here, and I was chatting with Ian, and he agreed to come in here and into this mess of a webinar we know and sit down with us and chat with us. So I'm really looking forward to today. A little bit about Ian. I met the way that I met Ian was through iRacing. Ian was involved with that program for a number of years, quite a few years, from the physics, building the modeling. And the way that I met him, and I think Kevin Bob at about the same time, was my son was racing in the MX5 Cup series and in the Mustang Challenge series, and those were cars that they were modeling for the simulation. And and it was great to be able to provide them with data at the tracks that they had, and being able to fine tune and make better the things that they'd built. And then my son Andrew was able then to they would send us those the files and the things that they were doing. We were able to test them, and I remember at the time Andrew was able to go in and say, yeah, it feels about right. I always shift right at that that crack, or that point, or by that bridge, or whatever it is. I'm always shifting it, and it's shifting a little bit early, and they were able to go in and tweak that stuff. The realism was really there, and that's where I first got to meet Ian. We passed a lot of emails around back then, and did some kind of cool things that way, so it was kind of fun. But Ian's got just a ton of experience, 34 years in racing all around the world. Started off as mechanic, crew chief. I did a little research there. I found some pictures of him jumping in cars too. He didn't share those with me, and I did not include those in some of my pictures, but a bit of driving experience as well. Driving instructor, motorsports manager for Pirelli, of course, the iRacing vehicle dynamics engineer side. But the last 14 years, that might that number is going to certainly continue on. Dedicated solely to the braking industry. So it's going to be interesting here with Alcon and PAGID. I'm going to say I say it wrong. And to be able to help us here today with some questions about braking and how to look at the data, and how some of the things to look for, and why you see certain things in the data traces. That's going to be kind of interesting. So welcome, Ian. I really appreciate you coming. I know you're a busy guy, and I take up a lot of time when we do these with phone calls and emails, and maybe a practice or two, but I appreciate you coming. Thank you very much for coming with us.
My pleasure. I actually haven't done as many webinars as the company wants me to do, kind of thing, but it's kind of busy year compared to last year, especially. So
I know you've been I know you did what was it, ePartrade recently, and going to be doing another one, and those are always so interesting to watch. So I think you did one part of that with Matt, if I remember right, from that has helped us a lot here.
Yeah,
So,
well, yeah, we're doing the EPAR trade thing tomorrow, and Mark Miller is involved with ours, so I know he was here last week. So
yeah, exactly. I'm digging deeper and deeper all the time into the old friend well to bring some really good folks in here to help us out. And Mark was very generous joining
yes.
us last week, and that's available on our YouTube page. And one last thing, as you're watching this on YouTube being taped later, make sure I'm going to chat a lot about links in the chat box, and I'm going to talk about some different things, but everything we talk about linking or showing will also be available to you in the description box down below on the YouTube video. So keep that in mind. Okay, perfect. So let me see if I can. Maybe we'll just leave that. We'll leave that. We'll go to this screen and chat a little bit. Leave that kind of there for a little bit. Ian, what talking about brakes and the fundamentals and with a bit of a data analysis flair, I'd like to chat a little bit about pressure sensors and some of the different things that we might use in order to do our data work. And one of the things that I get questioned occasionally is brake pressures versus brake position, and how those might be used between the two, and why is there power of one over the other? Are both really important? What are your thoughts about sensor types in motorsports that these guys may be adding to their cars?
Well, the one thing I tend to argue for all the time, and it seems like nobody either nobody listens to me or nobody wants to do it, is a brake position sensor. Like just throwing a string pot on the brake pedal to get an idea of what the travel is. Because that I mean, if the driver's complaining about a low pedal, or I mean, I kind of call a long pedal two different things. There's a soft pedal, which is brake overheating or like brake fluid boiling. And there's long pedal, which is just you have to stand on it to get it to stop. Long pedal typically to me is brake fade, where it's just not working. You're standing on it, you still have a hard pedal, but it's just not doing much. And a soft pedal where you can pump it up. The problem is that pumping it up also corresponds with knockback. So like Road America, everyone complains about knockback almost all the time. So, if you have a string pot or an LVDT attached to the brake pedal, so you get an idea of what the travel is, and you can compare your line pressure or your caliper pressure to your D cell, you can at least then identify what the situation is. And that's a thing that I think a lot of people should do, but don't, quite honestly. And that to me is the biggest thing that from a perspective now. And the other thing is, to be honest with you, a lot of the people that listen that read the old, I think it's the Bosch M Motorsports for the M4 line pressures and see that as a fact. It's not even close. It's just what the ABS module thinks the numbers are.
Interesting.
So actually, if you take line pressure sensors or caliper pressure sensors, that will differ from what the ABS module is telling the computer the data stream.
Interesting.
So having the right sensors in the right place is such a big deal. And I'll admit, I'm an old school guy. I'm not a fan of ABS because it throws so many variables in the system. I like to control the race car. I'm old school. I'm an old guy. I like H-pattern gearboxes and no ABS and no traction control. But quite honestly, it adds so much complexity to the system. It's hard to nail down what exactly is happening quite often. So
what are your thoughts about? We've had webinars in the past. One of them, I think it was John Block that came in and joined us, and he talked about the clamping pressure on pads onto the calipers, and it's not just a measure of the brake pressure coming out of the master cylinder, because there is so much that is affects that, right? Piston sizes, and then all the different things you go through. So brake pressure, while a great number, you just can't take that from car to car. It's a great number to see what you are doing as a user when you change a pad on that particular car, things like that. What are your thoughts about brake pressures and sharing that data, or thinking of it as gospel?
Well, I keep having teams that say, well, I'm running 52% brake bias. Well, you're running 52% line pressure bias.
There you go.
And that has nothing to do with your clamping force. That clamping force is all about caliper piston size. So getting the clamping force on front and back is correct, is the key. But it's basically, in theory, you'd need a math channel to figure out the actual clamping force. So, you know, we can play with it. We can change compounds to work around limitations, if you will. Sometimes, and this is a recent, like 3-4 years ago, I had this issue where I took our most aggressive pad in a car that really didn't need it and got them to work the system that way, because the caliper was so flexible that once they started clamping down pretty hard, the caliper body would flex outward. And the modulation went out the window because the whole caliper is doing this. It's got a whole added spring in the system. It wouldn't relax the drag until the foot was almost off the pedal. So sometimes the caliper stiffness can be a problem. Sometimes it's good, sometimes it's bad. Friction level, you can play with line pressures to get it right. And it's such a brake pedal field, in my experience, is such almost a personal opinion. I've seen Trans Am guys that have had a brake failure. They don't like the pedal going more than like an inch and 1.1 inches. If it goes to 1.2, there's a problem and they're slowing down. So they'll stand on with both feet if they have to get the thing to stop. So yeah, there's so much sensitivity to the driver, and especially somebody that's had a problem, they become hypersensitive in a lot of ways, and that's not a bad thing. Just it is.
Yeah, absolutely. You bring up a topic there that the brake caliper itself is there is flex in those, and I didn't realize that until a few years ago, and I was doing some data work, and we were swapping out those during a test day, and the calipers were measured the same size, and we were putting the same pad, but the driver feel and the stopping distance was far superior with one brand versus another because of that flex. It internally bridged, and some interesting things they were doing to make those things work correctly. Interesting. The one other thing to tie that together before we move on to the next topic, and I see some really good questions in the box there. David Arkin has a question that I do want to tie into with John Block's formulas we talked about, and you can go back and look at a previous webinar. I'll certainly have the link in the YouTube box below. He goes through the math channels on understanding how to calculate the clamping pressure inside of Race Studio 2. But the brake bias that we're looking at here on the screen capture, one of the things that I have used that for it was thank you, Robbie, putting the link into the chat box. That brake bias is something that yes, it's a starting point. And while you are right, you're biasing the brake pressure because that's what you have in order to do that quick math. An interesting thing is go out there, run your practices, the driver can adjust that on the fly typically. And once you get a number, then you've got a number to start with, right? And it may not be the clamping pressure, but it's certainly, if it's 54% front on that car with that system, at least you can get close to start the weekend off with, which is kind of nice. So do not throw away your bias channels because what we just said, but understand what it is, right? It is biasing of the brake pressures. That's kind of an interesting point. Another point that I did want to talk about, part of the questions that we have that people have sent in already, is proper bedding of new used rotors. This is from BZM31. Please cover proper bedding, and this is a deep topic and we're only going to touch upon it, but of new used rotors with new used pads in order to establish that transfer layer effectively. What do you have to add to our discussion here a little bit on bedding of pads and rotors?
A lot of times there are variations on a theme, if you will, within pad families. So if you're comparing ours to a different brand of pad, it's not uncommon to have I call it transfer issues. So it kind of looks, I always think of a properly bedded disc looks like this polished surface. If it's not bedding in properly, you're going to end up with, I kind of call it like, it looks like spread peanut butter, where it kind of gets the edge peeling up every so often. So you'll actually see that. If it's doing that, it's not bedded in properly. But the main thing is bedding in new pads or used new pads or new used rotors, however you want to phrase it. Putting new pads on new discs takes longer because you have to get everything up to temperature, and bedding discs quickly is a bad plan. I've seen, I got called on the carpet by a pro team a couple of years ago at Montreal. They were trying to bed brake pads on one of their qualifying sessions or something. And he tried to do it in like 3 laps and cracked all 4 discs on the race car. Because he basically drove left foot hard on the brake, right foot hard on the gas down the straightaways and just overheated everything. And with the cold bits being still cold and the hot sections being super hot, basically it created such huge stress risers in the disc it failed. The key is to do it slowly, bring it up to temperature in steps. And I always say it's just simply starting, let's say average turn at the racetrack, you break it 3 marker, especially like a chump car, champ car, AER, WRL, whatever. So if you normally break it 3 on the first lap, you break it to 6, second lap you break it to 5, third lap you break it to 4, third lap, fourth lap you break it to 3. Just do it that way, break earlier, break longer, lighter, and then just let the temperature come up over time very predictably. That's going to bring it in the best you can. And some pads, some manufacturers seem to have this you got to pull them out and cool them down to ambient temp or whatever to make them work well, blah blah blah. I haven't found that with ours. Generally speaking, I'll have guys bed in brake pads and discs even sometimes on the warm-up laps. And if it's discs, generally it's okay, you're going to be slow first few laps in the race, but that's the only option you have, or else they're going to crack. If you try to go too hard too soon, you'll have issues.
Yeah, interesting. The one of the things that when we were racing a lot and some of the stuff we were doing, I didn't understand fully why we were doing it, right? And I remember sending my son out there and reminding him to warm up the brakes, ride them a little bit on the warm up lap in either the Spec Miatas or the MX-5s or the Mustangs, and in the off road trucks even, and get some heat in them. We were doing it because of that it felt better in turn 1, right? That felt better the first time he needed to use them in anger. And but you talk about cold braking systems. Even if your pads are already bedded in, it's the second session on them, you go out there and get ready for your race. Road America, right? The data we're looking at here, you got a long front straightaway. You go into turn 1, and if you haven't warmed them up correctly, there could be some real problems that come from that as well, right?
Absolutely. I mean, and that's the thing. The first lap is always the most risky. And it's, the drivers you see everybody squirming, getting tires warm and all that stuff. And apparently now, and this is anecdotal evidence that I've heard, a lot of the drivers are now using the brakes more on the warm-up lap because it also brings the tire temps up.
Yeah.
You're heating up the rim, you're heating up the air in the tire, you're getting the pressures up where they need to be. And that's turning into a bigger deal with cast iron rotors. Carbon, whole different ball of wax. So and not totally my forte. I've got a little experience in it, but not a whole lot. But the cast iron side of it, I mean, at Road America, specifically Road America here, we actually, when I used to do the Trans Am stuff a few years ago, like 20, we would actually have to tape off the brake ducts, which sounds absolutely counterintuitive, but because the straightaways are so long, you'd heat shock the rotors 4 times a lap.
Wow.
Turn 1, turn 5, turn 8, and Canada Corner. You're using it. Everything gets pretty cool by the time you get down there, and you just have this huge temperature spike.
You go through that process every 4 times a lap instead of just once when you leave. That shows how good the air, how good the teams have made the rotors, how the manufacturers made the rotors, and how good the air is getting into the thing.
Exactly. So they cooled very effectively if you weren't careful, but too effectively at times.
Oh, interesting.
So learning how to manipulate the airflow and maintain the temperatures is such a big part of this whole thing. In my experience, I'm not a big fan of the rotor temperature sensors because everybody looks at the peak temps, and to me that's the last thing. That's the last thing I care about. I care if anybody has rotor temperature sensors on their race car, and I'm sure more than a few of us in this group have. Generally speaking, you'll see if you don't, I guess there's a sensor that has like three IR beams, so it kind of averages across the surface.
Oh, okay.
That's much more effective, because if you ever watch a dyno bedding of a disc, you'll watch this glowing hot band literally migrating up and down on the rotor, and that as it migrates up and down, I don't know why it does it. Nobody seems to have a good
Reason why.
None that I've heard anyway.
Yeah.
But I have seen it. The IR a single point IR sensor will sense that change.
Ah.
So the averages are more valuable, I think. But most importantly is the sort of the asymptote of where the trace goes down to the core temperature by the end of the straightaway. So as long as that's in the 500 to 600 Celsius range, everything's pretty happy. There's enough mass in the rotor typically to store the energy until the next straightaway, which is what it's designed to do. And it's not going to over temperature in a single braking zone typically.
Interesting.
So the asymptote, the bottom line, if you will, on the temperature trace on the rotor is really what I typically look for in data.
Very cool. And we're not going to have any data that has those temperatures, but people, very clear description of what it is, and people can look at it if they've got that.
Exactly.
Pad knockback. You've talked about it a little bit, and when you were talking about position sensors, we that's how people are using that a lot. And I've seen position sensor data. I've never had any on anything that I've ran personally, but and I've watched it, and we always see some of the cup racers, NASCAR cup racers that are racing on road courses, and they put the foot cams in there, right? And they're driving down the road, and Boris said was one of the first ones I think I ever saw, and he brings his foot over and he just gives it a couple of taps, and you think to yourself, okay, well, is it just an insurance thing or what? But you're pretty clear on, and everybody's doing it, right? And
yep.
My son did it as well. You're over there and you're taking up this pad knockback, and give us a little bit of a background. Why does that happen? How does that happen? And is there anything we can do about making that stop?
I mean, the bearings are always the first reason for knockback. In a car that has sealed bearings or a cartridge bearing system, like most production cars nowadays, most of the time it's going to be, if it's a solid mount caliper, whether it's radial or like a tab mount, like an OEM style mount. If it's a solid mount caliper, you have to watch your bearing tolerances. It'll kick back a little bit. If you hit a curb, the spindle is going to flex a little bit. The NASCAR guys, to be honest with you, I don't know if anybody's ever seen an actual stock car upright, but it's probably 50 pounds of forged steel, and it's not very well braced. It's not a road race hand fabricated super hybrid anything. So they're heavy. They don't, and you've got a heavy wheel on a heavy upright, and any extreme force is going to, the upright's going to resist movement, period, just inertia. So what happens is the whole spindle and axle and everything just kind of twists in the mounts. So the caliper then maybe is semi-rigid, call it, and the disc and the rotor are kicking this way and back and forth relative to the upright itself. So that's typically the big reason for NASCAR, why they have so much knockback all the time. And some of them did have decent mounting systems, bells, disc and bell assemblies for everything. But once it gets tired, worn out, it gets worse and worse. And some of the guys that you'd see weren't necessarily top budget teams, and they have more problems obviously than others. So,
and there's a couple of solutions to that, right? There's residual pressure valves is something that
yep.
I've heard a lot about, and then knockback springs in the calipers.
Yep.
Tice asked a question about what's your opinion on knockback springs in the calipers, some experiences, and residual pressure valves. What do you think about those?
I don't see a problem with it personally, as long as they're within reason. And sometimes the residual pressure valves, sometimes I've seen them be really strong. If you need a strong one, you probably ought to look at caliper mounts, honestly. I mean, back when I was out at Alcon, specifically doing the brake calipers and discs, the hard parts, if you will, of the brake system, the biggest thing that I think I always said was reinforce your caliper mounts. Stiffen up the caliper mounts as much as you possibly can on the race car, because most of the time the problem is the caliper. You know, you've got the calipers offset from the mount, so as it applies force, the whole thing twists anyway. And even if you've got a really solid mount where this side won't twist that way, I mean, TA2 cars are notorious for this in some respects, or at least it used to be early on. But now, even if it's got a super solid mount, caliper body is going to try to lozenge because the inside is held fixed and the outside is still going to try to move as the pad applies force. So, you know, that's why I like some of the calipers, you see this asymmetric design to them. So it's about controlling the deflection in that specific orientation. As the inside half the caliper is solidly mounted, the outside is going to try to migrate some. So that does create some issues also, keep in mind, because as it's moving this way, it's also working on an arc. So the pistons are clamping down harder anyway. And as you come off, it's going to kind of back it off.
Open up some
more as well, which is good. We like low drag, but not to the point where the driver's pumping before the next braking zone. Yeah. And as far as knockback springs, back in the good old days of the old champ car, the old championship auto racing teams, Indy cars with turbos and you know, the big horsepower numbers, I saw teams that were running double knockback springs and calipers at places like Road America because they couldn't stiffen the upright. So when they jumped all over the curbs, it would flex everything enough because they had downforce and horsepower and big tires. The knockback springs, they'd run double. So you've got a 6-piston caliper with 2 7-pound springs per piston. So 14 pounds of clamp on each piston on all 6. So that's what 84 pounds of clamping still on the pads in place. So it worked. It was the solution that was available at the time. Better solution would be stiffen the upright, but apparently that was not acceptable. And a lot of it was because they had all those cool CNC milled air holes out the middle, kind of like with the carbon upright or carbon brakes all have tons and tons of airflow. It's not great for racing, simply put. So things flex a little more when you try to get more airflow through it all. But yeah, the residual pressure valves work better than I ever would have expected them to be honest. Especially on older style calipers. If you've got like an old GM metric late model or something, I mean, it's gonna, because it's a pin mount caliper and the one big massive piston and everything's flopping around a little bit, having anything to keep that massive piston from being pushed back is a plus.
The driver's not going to have to do it as much, and that's less problems
confidence
for them, and it's quicker to the pressure you're after.
Yeah, it's a confidence issue. The more confident the driver, the faster the car he's going to be able to drive. Simply put, is the way if the driver's comfortable, he can do whatever he needs to do. And he doesn't have to adapt every braking zone.
Yeah, that doesn't inspire confidence.
Yeah,
The residual pressure valves, there's different pressures, right? Kyle asked the question, what is the range? He's got 2, 10, 50. What are they pretty typical on a range, or are they? And I remember 7.5. That was something I think we used, but I might be my memory.
Yeah, I'll be honest. I don't use. I've kind of always. I've steered away from them.
Okay, because you'd use the spring instead, or a better setup.
Yeah, basically. I mean, most of the stuff that because I'm mostly in sports car racing typically. Generally, we'll try to fix the problem, not band-aid a solution. And it's kind of a snippy response. I hate to say that, but
I don't think so, because a lot of our folks that are watching this are many different forms of motorsports, but in the sports car side that you've been talking about, many of our guys, and certainly me, we race production based cars, and that we just can't throw a different bearing and a different some of those different things, and you're going to have it. So I understand your point is well made.
So yeah, I mean, a racing caliper. I mean, racing caliper design has changed in the past 25 years. So piston seal design, piston pullback, how stable it is in there, and yeah, this OEM based stuff, we have to make allowances for it. I mean, the chump car team I play with, occasionally we tend to have brake issues occasionally, and I've done everything I can to fix that. But I've managed to avoid residual pressure valves or knockback springs.
Okay.
Just to be honest, mostly by frequent rebuilding. New seals. New seals make a huge difference.
Yeah, there you go. You were chatting yesterday, and just to kind of tidy up this particular topic a little bit, we chatted yesterday a little bit, and you talked about what you just mentioned in the old Champ car, that they did it at Road America. They were adding those, and there was value to that. But when they'd go to an oval, that we all watch the NASCAR guys go to qualify, maybe at a Daytona or a Talladega, where they don't touch the brakes, and they always talk about the crew spreads the pads apart. Do not touch those on your way out. There's drag. And how much do you see there with that kind of stuff?
For NASCAR, I don't know, but I did do a test at Homestead a number of years ago. Too many to count, but it was a back-to-back IndyCar test, so it was back in the lower, still in lower horsepower, not Champ car era, and we did a road course test on the first day and oval the second day, and some of the guys left the road course calipers on, and found they were down like 4 or 5 miles an hour on the straight. So they switched out they pulled the calipers apart, pulled the knockback springs out, and gained that speed back that they were expecting to see, which is significant, but it's also, they're relatively low horsepower compared to what the old Champ cars were. Champ car guys would do the same thing just because it was faster, because any mile an hour counts at the end of the day.
But it shows that there's drag and at that sustained high speed, and it pulls down that top speed just that little bit. It's a big number on the timing sheet, right?
Absolutely.
Yeah, that was more than I expected to see too. So that's interesting. Again, ways to use data, use engineering to make our race cars faster. It's just an interesting topic.
Absolutely.
So, one other topic here that was in the questions, and I want to jump into some data here shortly, but fluids. We've been talking about calipers. We've been talking about pads. Do you guys work in the fluid side? Do you guys make fluid, or do you have any opinions on fluid types and different things that are going on there?
Yeah, absolutely. I mean, we do have a racing brake fluid, which is always, is it .4, .5.1? Because remember, .5 is the silicone-based stuff that belongs nowhere near a race car, or .3. .3, .4, .5.1. Almost every racing brake fluid out there is compatible with all of those, the 3, 4, and 5.1. It's compatible, not meets the spec.
Optimum.
Well, there's one of the seminars I was doing a little while ago for a university I went to. We talked about viscosity, and viscosity temperature is, I think it's -40 C / -40 F is one of the points. And I think the viscosity of most racing brake fluids is around 1500 centistokes. Well, honey is about 1500 centistokes at room temperature. So at -40 F or -40 C, same thing, you're trying to pump honey through the brake lines. So using racing brake fluid on a rally car in Wisconsin in the middle of winter,
Sweden,
might not be the hot ticket for good brake response, or clutch response too, for that matter.
Yeah.
So everything has a place. Once you get above, say, 50 degrees Fahrenheit and up to whatever temperature, up to 300 Celsius typically for racing brake fluid, it's all good. It's all perfectly usable. But the low temperature stuff is the place where most racing brake fluids do not meet DOT specifications. It just gets too thick. Other than that, it's all perfectly compatible. It's just not the best choice.
Interesting. And moisture intrusion is the big deal, right? So how often in race cars would you be suggesting folks bleed the brakes or completely purge and replace brake fluid in a race car?
Well, I mean, in reality, most pro teams or well prepared teams are going to go through the brake fluid probably half a liter every race weekend.
Okay, they're doing it in between even sessions, obviously.
Yeah.
But for your amateur racer that's out there doing some stuff, you get a couple races, or is even that too far?
No, I would say, because I actually tested the brake fluid on my own race car here in Colorado. I mean, I'm a little OCD. I'm kind of ex-mechanic, ex-crew chief. To me, every time I track dayed the car, I would go out, I'd pull the wheels off, crack the bleeders, like 2 pumps through the brake pedal, close it back down, done. And it was just keep the hot fluid that had been in there in the caliper from degrading and get fresh fluid in there. It keeps the calipers from rusting, keeps moisture out of there, all that kind of stuff. But to me, I mean, even as a track day guy, just a track day guy, just to go out and play, I probably went through at least a bottle of fluid every season, just as a matter of course.
But it was gradual. It was virtually every event. You'd pump a couple pumps through, and all 4 of them, and you're off and running. Okay.
Exactly. So
preventative as much as performance. Right?
And I never had a problem in my car on the track. Okay. I had a problem in somebody else's car on the track.
Yeah, sadly.
Learn the hard way. Always learn the hard way. Unfortunately, I'm not that smart.
So the takeaway that I get from the fluid discussion, I know we've have a couple of guys that talk with me that watch these webinars that race snowmobiles and rally, and those guys may be looking at brake fluid in a slightly different way. That's an interesting thing. And then the other side, being, hey, just crack those things open every event. If not, if you have a little time during the weekend to get some fresh fluid into the caliper part itself, right where the heat is.
Yeah, I mean, if you're swapping tires front to back on the car, if it's a square setup, you already got the wheel off. It's not that big a deal to do it.
So. Perfect. And one more before we jump into some data. Do you, Andy asked the question, do you brake balance to maximize the negative G in a straight? Are you, if you're working with a team to kind of optimize some things, is it really about the optimum G's, negative G's in a straight, or for better balance on trail braking, or for XYZ? When you're trying to help them out, how do you, is it feel, is it or is it all of these things?
It's kind of all of the above. Yeah. I hate to say it. It's
exactly.
such a blanket answer. Generally speaking, our goal is to maximize the deceleration in a straight line, because that's where the majority of the braking is being done.
Certainly the place you would start, right?
Right. Front-wheel drive cars need a different something than a rear-wheel drive car, because they tend to understeer. So a lot of times you want to get the car to rotate at turn in. So you may have, in those cases, you may want more rear bias and let the car rotate so you can get back on the power and down the straightaway. So there are variations on every theme, and typically with those cars, I would say bias adjusters are not uncommon on front-wheel drive cars for that, because it works well for that specifically. For most other stuff, I tend to point towards a bias, a dual master cylinder setup if that's the option. Otherwise, if it's a factory master cylinder, for example, I will sit there and help try to dial in brake friction front versus rear, because most street cars are designed for street use with XYZ tire, and it's probably an older car, maybe with or without ABS, but it's designed for a low grip tire, and now we're throwing more grip, so we got more load transfer, so now we need more brake bias to the front than the rear, just to stabilize, keep it all stable in a straight line.
You mentioned something, and I thought, okay, let's jump into the data and let's dig in a little bit with a topic, and of course we'll go anywhere we wish to go. The data I have here is some data that we have used in previous webinars with this DPO2 car, that where we're showing front brake pressure, rear brake pressure, of course, a speed trace, and I've got bias up here, but just so we can see it, I'm going to zoom in a little bit on this braking zone into turn one, just so we can kind of look at the shape of the brake pressure. Something you just mentioned triggered me to think of, to ask this question. We've got all these friction materials, and we as racers, we hear this initial bite versus all these different ways that the pad may feel different as you're applying it. When you see a brake pressure like this, discounting this little drop off here, I think there was a downshift right there, but you see this huge bite, this huge amount of pressure that the driver threw at the rear brakes, and then it's trending off. And if we back up, we can see that's kind of typical of this particular car. Yep. What does that tell you when you're looking at that?
I mean, to me, that's actually kind of the ideal trace, maximizing the pressure early in the straightaway, because if it's a DP car, DPO2, so it's got downforce, so it's got tons of grip, and it's got a huge amount of inertia in a spinning tire. There's just, think about all the mass just ripping away out there. And it's going to have to require a fairly steep drop off in pressure, because as it sheds speed, sheds downforce, loses grip. And as long as the pad is working and it's in a fairly good temperature range, the driver has a very consistent feel to it. He can just back off as the car lightens the load and turn into the corner and transitions nice and smoothly. In that respect, it looks good to me. Whereas I guess it would be turn 3 Road America, the one just to the right of that. Either his upshifting or downshifting is a mess, or he was trying to avoid hitting somebody is all I can guess.
Yeah.
But you know, that initial hit is less, and then it's almost like I need to slow down more, and that to me is always less than ideal, obviously. But the general trend is still the same. And to me, this tells me that the brake friction materials are pretty good. They're working in the temperature range they need to, because it's very consistent. I have seen some where some guys, I think Kyle mentioned earlier something about having brakes problems at Road America last weekend. I'll see traces where it'll drop down, but later in the braking zone, they're still trying to slow down more, and they actually have to start raising their line pressure again, where it goes back up, because they've chosen a poor compound where it's now operating above the temperature range that it should be. So now the brake pad is fading, and they're trying to get the car to stop just as hard as it was, and they have to push that much harder to get the car to lower it down.
And something that I see here, and let's tie this all together a little bit more. Certainly, this is a high aero car, and they're going to need to come back off of the clamping pressure needs to be a little bit less as they get down, just because the grip is going away. But what is the and I know this is a very wide-ranging answer, based on a lot of things, but pads, when they contact the rotor, there starts to be a temperature increase, and pads become more effective as well. So you can also hit this, and then the driver is releasing a little bit of this pressure, but the actual clamping force and the mating surface between the rotor and the brake pad is still there, right? Or if not, yes, climbing with temperature for a while. Yep. So is some of this them releasing some fluid pressure, line very pressure, because look at the trace is very symmetrical, right? Even though he's pulling this away, so it's not just aero that he's releasing, but it's also pads must be some clamping force there.
Absolutely.
Interesting.
And actually the turn 3 sort of, right there, it's actually steepest, where he's got highest on the pressure, and then it kind of levels off. It kind of has a slight downward curve later in the braking zone, you can see. Yeah. And that to me would indicate he's probably close to the limit, and that's an effect of the the downforce changing as it goes into the braking zone,
and the temperature of the pad coming up. And
exactly.
Okay.
And, gotcha. And so he's fighting two things at once. Which is why I think the pressure trace is fairly steep from the driver's release.
And that's where I actually that was one of the topics when I thought about talking about with you with brake pads, is there's always this discussion of, I like X pad and I like Y pad from the feel, and I get this good initial bite, and then it's not so harsh at the end, or it doesn't build so much, and maybe they're a non-ABS car. Spec Miata comes to mind, where you're driving down in the corner and you start to trail brake, and that inside rear tire, if you've got a brake pad material that does this, where this really works well on this DPO2, that may not be a great pad material for a Spec Miata or a non-ABS car that's going to lock up that inside tire. Is that a discussion you have, or you think through when people are asking you about what pads to use?
Yeah, I mean, it's all, there's so many variations on a theme.
So many variables.
I think our portfolio is like 16 or 18 different friction compounds now that I typically work with. So there's so many, friction level is the same, bite is different. So the initial hit feels a little different with this compound, but the ultimate stopping power is comparable, and how it leads in, how linear the relationship is between pedal effort and stopping power. All these things are such a big component in that I lose track.
And there's science to it, but the end of it, there is so much of it is driver feel and driver preference, I suppose, yes, right?
Absolutely.
Okay. There's a big part of it is that.
Data can only tell you how it's working. The driver has to tell you how it feels.
There you
Bottom
go.
line.
Very, very good. There is such a difference there. There was a question that I just noticed, and it kind of steps back to calipers just a little bit, but Kyle Watkins asked a question. Assuming the math puts the same clamping force with calipers, right? And why is 6 pistons calipers better than 4? Why are 4 better than 2? Right? So much that organizations are assessing different performance multipliers for different calipers that you may use. What do you have to say about that question?
Well, I'll tell you right now that the new Porsche 992 Turbo has a 10 piston caliper coming out.
6. Oh, so 2000, right?
Exactly. That's old news. 6 pistons, whatever. And oddly, the thing I've learned in the last, I'd say 10 years is that like a 6 piston caliper is great because if the pistons are sized correctly, it does spread the load across more of the back plate.
So you get less of that cupping that you were talking about earlier.
Exactly. A 4 piston caliper is going to have bigger pistons for the same clamping force than a 6 piston caliper, or three on a side, 2 on a side, 1 on a side kind of thing. And the thing is, most back plates are anywhere from 5 to 6.5 millimeters thick.
Oh, yeah.
So depending on the application, depending on what the OEM manufacturer requires. So if you've got huge force in a big back plate, pushing it this way, eventually the plate's gonna flex.
Interesting.
So it'll actually end up banana shaped. And that's certainly not the ideal solution.
And additional pistons in the caliper reduce that a ton. Yeah.
And it's a spring. I mean, now you've added a spring to the system, so it's even less consistent.
Driver feedback, driver feel is going to be crazy wrong at that point, right?
Because when he tries to bleed off, it doesn't do anything.
Oh, interesting.
So the increased pistons are definitely about evening out the pressure distribution on the back plate of the pad. But the thing that I find now is that, like, you can buy some big brake kits that are a 6 piston caliper on a car that's fairly big and heavy, front wheel drive or all wheel drive, depending on the specific model. And there are some that have a fairly narrow annulus, so the difference of the OD and the ID of the friction face is smaller than the stock pad, smaller than the stock disc, which is absolutely the wrong way to go. Because most of the time it's still about the same thickness pad as the OEM. So now you've actually reduced the friction volume.
Okay.
So it's less consistent because it takes less energy to heat it up beyond its limit. But the OEM pads have all that extra area vertically, if you will, or on the side, depending on the position, obviously. But all that extra surface area is a huge cooling opportunity for the disc.
Wow.
So covering up more of the disc with this massively long pad means you're reducing the cooling efficiency of the disc itself, and heat's our enemy in this application.
Heat's your friend early, but heat's your enemy at the by the time it rotates back around. It's a crazy world you work in. There's so much to this.
Yeah, we're taking a huge funnel, and it's got a little pencil-sized hole at the bottom. It can only hold so much. Once you start dumping in more than it can funnel out the bottom, you're done. So
yeah, you need a long straightaway.
That's precisely it.
Great chatting with us. I mean, there's a question I want to go into in the data here in just a second, but for all of you that are watching live here today and in YouTube later, there is so much more to these to your braking system for you to think about, and understanding that just that whole thing of the pad material and the brake pad backing plate, flexing with the calipers, and why those additional pistons is something to really think through. The quick question on that can deserve a pretty brief answer, but you get a 6 pad or a 10 pad caliper. Are they generally all the same size, or do they make the one ends maybe a slightly different piston size?
Well, depends on the application. Depends on whether it's a handed caliper, if you will. So it's like a left front caliper that's behind the front axle.
Oh, okay.
So it's at the 3 o'clock position as you look at that side of the car. The lowest piston is going to be the smallest.
So they do different size of pistons and calipers is very, very typical.
Yeah, absolutely.
Interesting.
And it's actually, there's
Because of the
actually,
leading edge and the way that it works. And,
right, yeah,
okay.
because it pivots off the tailing edge of the back plate. So it
Wow.
kind of tries to cam action itself into the disc.
Science. There's a ton of engineering going on here, and very, very, very interesting. There's some more for us to think about. We've only had an hour to chat about it, but it's there's some very, very interesting things that we found out today. I hope everybody's enjoying it. A question that somebody has, to bring this back a little bit to kind of close it up inside the data, is somebody named Tech asked the question, Roger, do you find the 50% baseline, we're talking about the bias channel down here on the bottom, for bias math channel to be helpful? I have my bias channel set to 0 until the pressure threshold is reached. In other words, the way that he has talked about this is he has a 0 value here in this box. I have a 50. I'm going to bring up the math channel. We'll look at it real quickly. And once whenever a certain amount of pressure is exceeded, then the math starts, right? And if we bring this math channel open real quickly, and I bring the brake bias one open, let's bring this where we can see both. What I've done here, and you can do it either way. I happen to like it at 50 because it's in the middle of the screen. I can do my my scaling where it stays in the middle of the screen, and it makes it nice and comfy for me, but it's really user preference. What I'm looking at here is I do the math for the bias. We're not going to go through all of that, but I do have a number here that I said it needed to exceed 30 psi. This is a full-on race car that has really good sensors in it. Normally I run that a little higher, maybe 60, 70, 80 psi before the math starts to kind of overcome some things. But 30 psi. So this math is not starting until it sees 30 psi. When that's exceeded, it does the math, and I turn it into a percentage. And I do use this number here in the math channel is, where do you want it to start? The questioner is saying he likes it at 0, and then it jumps up to whatever that number is, and you can see the peak come up. A lot of people like it that way. They start with a baseline of 0, and then it pops up to wherever the bias percentage is. I like to put it at 50. It's a percentage. It's a personal preference. So I do happen to like doing it, having a brake bias number. And if a driver comes in and tells me, hey, you know what, halfway through the race, I was kind of tinkering with it, went from dry to rain, or whatever it happens to be, we end up with a bias number that for that car and that driver and that track, they really liked it. It goes into the notes, and then I can dial that in sitting in the car before the car goes out and give a bias number. We've chatted about that it's a bias of pressures, not necessarily clamping force. So keep that in mind. But there's a little bit about the brake bias math channel. If anybody has a need for that and can't grab that from the screen, write me an email note when we get done. I'm happy to send that out to you, along with some other math channels that we've come up with. So brake bias, is it something when you're at the track? Is that something that you will look at, Ian, when you're working with teams, with those caveats of some of the questions we've already had?
Yes, quite often. And with ABS, it just gets more complicated.
Yeah.
Because if they've got wheel sensors, caliper sensors versus at the master cylinder line, front, rear kind of thing. So there's some, it makes it a little tougher. But the big thing to me is always about trying to get consistency. And again, it's not about, I talked about clamping force earlier and bias. It's a reference point. Any reference point is better than no reference point, simply put.
Absolutely. Information is data is good, right?
Yeah,
at the end
absolutely.
of the day.
And the more consistent it is, the better off obviously it is. But also on the brake bias trace, for example, I'll always point out, and quite often you'll find this, the bias bearing, the spherical bearing that's in the bias adjuster, is one of the most neglected bearings on the car. It gets a lot of sticks. If you start seeing, pedal like pressure changes and it goes bigger on one than it should versus the other, typically it's because that spherical bearing is binding up, it's sticking.
And while Ian and I did not chat about this yesterday, I zoomed in on some data that's actually where I was going to end this, on how I use bias a lot, not just for the performance side, but when to work on things, when to look at some things. And I just zoomed in on this particular braking zone. And this is getting onto the front straightaway, I think, at Road America. And what I notice, and I start to really, it concerns me a little bit. Another reason why I actually bumped down that math channel down to 30 psi is I really wanted to see the early application of the brake pedal and where the brake pressures were building and releasing. And what you see here is as the driver, I'll just pause right there, right? Here, there's more rear brake pressure than front, and it's giving us a low front brake percentage of 41. And then as the driver gets up there and is actually applying the brakes up into let's say he's dabbing the brakes here. He's not using the brakes a ton, but now it's in that 50. The front's a little higher, typical road racy kind of numbers that we might see. And then as he's releasing the pedal, it's all of a sudden there's more rear brake than front. Now, maybe that's something they want, but that is a concern to me as somebody that's prepping the car, as a driver, as a data guy, saying, boy, it is that balance bar or the tool that particular car uses, is it working correctly? And is it giving us more rear brake on initial placement and on the release? And does that have to change the handling of the car and what the driver feels? So I appreciate you saying that, Ian. That worked me right into it. Good job.
Unplanned and everything.
But it's an important part, and I'm glad that obviously you've ran into that a lot as well. And even at my level of the little bit I do, this is something that I have found a lot. And to bring it back, some of us are here that I know we've got a good number of folks that race UTVs and off-road trucks and stuff that watch our videos, and some that are in watching live right now. The off-road world, with all the dirt and all the stuff and all those things happen, when they're trying to get those things to turn and do what they do, they start with a heavy rear percentage anyway, and then sometimes these bias bars, these bias adjustments are heavy on the front when they first start, and the cars just will not turn either early or late, and it's a big part of it is this braking bias bar. So everybody keep an eye on that as you're working.
Absolutely.
So perfect. I am sad to say we're about out of time, but there was such a good bit of information here and lots of good questions. I didn't get all to all of them. I'm sorry about that. What we tend to do is there's some open questions. What I'll send those questions. We'll either try to answer them ourselves, and if there's something that was really technical, I'll ask Ian to help me with some answers. And we always put all of our questions and answers together in a document and attach them. It takes a few days, maybe a week or two, but especially this time of year that we are just so swamped with us and our techs with being at the tracks. But we'll put those together in a document, and they'll be down below in the description of the YouTube box. I'll link to it there. So I appreciate that. Let's bring up this back again. Let's talk a little bit about where this video goes. Just like all the rest of our webinars, we record them, we stick them out on our YouTube site. If this will be number 158 that we're putting up there. All of the webinars that we've done so far, plus tons of other video information, is out there to support and learn about our products and mainly about just analyzing data. So go out and take a look at that, and anything else you may want to look for, it's probably there as well. So we're a customer support company that happens to sell racing electronics. That's the way we look at it. And companies and guys like Ian are out there just supporting the products and the things we do. It's an important part of motorsports. Give us a holler if you have any questions about your data. We got some contact info for Ian here in a second if you have some questions about braking stuff that he works with as well. So give us a holler. Big on the customer support. We're in the midst of doing some driver coaching webinars where we talk with driver coaches from around the country here, and some of the tools and tips that they use when they're looking at data with coaching driver. It's become very, very popular. I get a lot of feedback, and it's kind of cool to see ways of looking at data that these folks have found that have helped other people get faster. We're going to have another episode of that next week with Andrew Wickstrom. Andrew is a driver coach and a prep shop up in the Northeast. What's interesting about Andrew, and the reason that I brought him on, and I had to, he's been a little bit hesitant. I've been working on it for about a year. So, but what I really like about Andrew is he has a company called Tactirian Driver Development, and what I like about what he does is he specializes in driver coaching, but driver coaching, track day guys and club racing folks. So he doesn't go, he does some certainly, and he's very good, and he could do it if that was what his wish was, to go and coach professional drivers. But what I really like about what Andrew does is he's coaching the track day and the amateur racer a lot, and which is a lot of our customers. So really looking forward to having Andrew here. I know I met him 7, 8, 10 years ago, and he's come to a couple of our seminars, and he works with all different data systems, but works a lot with AIM and Smarty Cams and with customers. So looking forward to chatting with him about some different ways that he has used to teach folks to go faster with AIM data. So that'll be fun. Again, Ian, I appreciate it. It's been a great time catching up and chatting with you. And this was probably one of the best technical webinars I think we have done, and it's been enjoyable. I appreciate your time. I know it's a very busy time for everybody right now. You mentioned that some people watching the video right now may not have recognized you without the hat, so I made sure I included a picture.
Oh, wait.
There's the Ian that everybody knows from the track, right? So so perfect. But so it was great to see you without your hat too. So I appreciate you being here. Is there anything else you'd like to add as we kind of close this one down?
No, I just thank you for the opportunity. I mean, it's apparently Kyle knows where I'm from because I'm Southeast Colorado, inviting me to High Plains Raceway.
There you go.
But that's, I'm a car guy. I love this stuff, and I just like sharing the information. Honestly, I find it really rewarding for me, most importantly. So.
And rewarding for us, because there's been so many things. I'm speaking for everybody, certainly speaking for myself as much as anything. I've been around this sport for quite some time, and while I've thought about a little bit of some of the stuff you mentioned today, you brought it right to the forefront and chatted about some things that I haven't thought deeply about, and I hope everybody gets something out of that and rethinks their braking systems and pads and ways that they prep and of course use the data to check that out. So I appreciate it. Thank you very much.
I only work on this much of the car. It's easy to get good at it.
I hear you.
Easier.
Yeah, so. There you go. Thanks again for coming. I appreciate it. Thanks for being in the sport. Thanks for being out there helping everybody. It's truly appreciated by everybody, and look forward to seeing you at the track soon.
I hope so. Well, take care. Good to see you. And thanks everyone for coming out.
Thank you, everybody. I appreciate everybody being here. See you next week with Andrew. It's going to be a good time. See you next Tuesday.